Okay, this is the Check Your Understanding on page 180. It's from 14.1, and it says determine which points are solutions to the system. So remember, that means that the point that I choose has to make both equations true. So I'm going to go ahead and start with the last one. Let me just start with this point here, -1, -2. So -1 comes first, so that means it's the x value. So if I check this one where -2 being y equals 3 times -1 being x minus 5, that means this whole thing should equal -2. So 3 times -1 is -3 minus 5 that means -2 equals -8, and that is not true. So that means this point cannot be true. So let's go ahead and start with the first one here. So again, I'm going to try in this equation. I'm going to have y, which is -2, equals 3 times 1, positive 1 though. So I'm using -2 for y and 1 for x, minus 5, and I have 3 minus 5 equals -2. So that one does check. So that means I now have to check the fraction one to make sure it works. So I'm going to put a positive 1 in for x and a -2 in for y again. So I have -1/4 times 1 minus 7/4. So I really have -1/4 minus 7/4, which is -8/4, which equals -2. So yay, both of those work. Okay, number 15 says, create a table of values to determine the solution to the following system. So a table of values means that I'm going to have an x, and I'm going to have a y1, and I'm going to have a y2, because I have two equations. So I'm going to make the top one my y1 and the bottom equation my y2. So when I plug in an x, so the easiest one to plug in here, I'm going to say is 0. So when I plug in x for 0 here, that gives me 5 times 0 is 0, plus 4 is 4. When I do a 0 here, 2 times 0 is 0, plus 1 is 1. So that's my first table or the first value I always pick. Then I go ahead and pick a 1. So if I put a 1 in here, 5 times 1 is 5, plus 4 is 9. If I put a 1 in here, 2 times 1 is 2, plus 1 is 3. And then I kind of look and see what's happening. Are the points getting closer, or are they getting further away? Because if they're getting closer, I need to keep going in the direction that I'm going. But if they get further away, then that means my solution, remember that's where the graph will intersect, I'm going further away from my solution. So here, the difference between 4 and 1 is 3. The difference between 9 and 3 is 6. So I'm going the wrong direction. I need to now go backwards a little bit. So I'm going to try -1. So if I put a -1 here, I get -5 plus 4 gives me -1. If I put in a -1 here, that gives me -2 plus 1, which gives me -1. And this is what I'm looking for the whole time, where my y's are the same. So I found the solution. So the solution is when y is -1, when x is -1, both y's end up being -1. So that is how we use our table. Number 18 says, I'm skipping over 16 because it says to do a table and a graph, but since I just did a table, I'm going to do a graph for number 16, which is actually what 18 also says. It says use the graph in item 16 to determine the value of x and y1 and y2 where they're the same. So if I graph the equation here, y equals half x minus 6, and y equals -5/3 x plus 8/3. So I need to start with some points. This y1 here, I want to start with 0, -6, because that is the y-intercept. When I put a 0 in here, this whole thing becomes 0, and I get -6. And then I'm going to move a rise of 1 and a run of 2. So I have my graph on the other page, so it's a little bit tricky here. Okay, maybe I need to zoom out. Make a little minor adjustment here. Okay, so 0, -6 is right here on my graph. And then my slope was 1/2, so I'm going to go up 1 and then to the right 2, because both are positive. So I'm going to go +1, +2, and I have 3 points in a row. So now I just need to make a nice straight line here. And then y2 is a little trickier because I have -5/3, which is still easy to do as slope, but my y-intercept is 8/3, and that's really hard to judge. I need to find a whole number. So the easiest way I know to do that is to find something that would cancel out and give me some whole numbers. So I'm going to try a negative, let's see, let me try a -7. That should give me a good value here. 3, which equals 6. So that means I have -2, 6 is a good point to start with, and then I can just move my slope. So -2 is this way, +6, 1, 2, 3, 4, 5, 6. See how different that is. Whew. Okay, and now I'm going to move down 5, 1, 2, 3, 4, 5, and to the right 3, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. Ugh, and that is just a beautiful coincidence that it's landing on a nice pretty spot. Okay, so as you can see, sometimes graphing can mess you up, but I have a solution right there, which is 4, -4. I don't know if you can read that. Let's make it a little darker. Okay, and that is my solution to the system of equations by graphing. Now, of course, you could make a table and find it like we did for number 15, but that's it. So that's all I have for 14.1 today.